All right, let's give these sample problems a try. On number 1, we are solving the square area formula for its side length. So I need to start with the square area formula, which is A is equal to side squared. Here, this A needs to be improved. Okay, that's better. All right, so I need to get S by itself. Well, this is very similar to the previous question that we just worked on with the area of the circle. We need to get rid of a square, so we're going to just take the square root of both sides. Right. Over here on the right-hand side, the square root and the square will cancel. Let me go ahead and flip the equation around. So I have S is equal to the square root of A. Well, just think about this for a second. Let's say that you had the area of a square, let's say it's 25. What was the side length? Well, the side length is 5, and you got that by taking the square root of the 25, which is what this equation is saying. Okay, let's look at number 2. Solve the rectangle perimeter formula for its width. P is equal to 2L plus 2W. Now, I showed you on the previous video, I showed you how to do this slightly differently, and that was if the 2 was, say, factored out of this quantity. And right now it's not. So I'm going to do this again, slightly differently, but end up with an equivalent answer. Okay, so I want to solve for W, but first I need to isolate the 2W term. The 2W term is currently being added to the 2L term, so I need to get rid of it by subtracting it to the other side. So I would have P minus 2L is equal to 2W. And then one last thing is I need to get rid of this 2. And I can get rid of this 2 if I just divide both sides by 2, and they would cancel out on the right-hand side, and they cancel again because they're essentially a fancy 1. All right, and then let me flip this thing over, and I would have W is equal to the fraction P minus 2L over 2. Now, you could, if you wanted to, divide this 2 into both of these. Don't make the mistake that these two 2's cancel out, because they don't. It's like a distributive property. It essentially is. You're distributing the number 1/2 through the top of this fraction. So if you did simplify this, and is it really simplified? Probably not. If you just divided the top by 2, you would have P over 2, and then on this term, that's where the 2's would cancel out, just minus L. And that's how we saw it the first time. So either one of these answers is perfectly acceptable. On number 3, solve the parallelogram perimeter formula for a half. For a half, I don't think that there is a 1/2 in that formula. Here, let's take a look at what that formula is. The perimeter, well, you got, it's basically the same thing as the perimeter for a rectangle. We just use different letters. We have 2 A's and 2 B's. And you can see that we don't have a 2 in here at all. Let me restate that. We have 2's, but we don't have the number 1/2. Okay, so you can be pretty clever about this if you do this. Watch. What if I just multiply both sides of this by half? Ooh, if I do that, that's perfectly legal. You can multiply both sides of an equation by whatever number you want to. Huh. All right, so if I multiply this by a half, I will have the 1/2 that I need over on the left-hand side of the equation. So I'd have 1/2 of P. Now, if you take 1/2 of each one of these terms, again, it's like a distributive property. This 1/2 times this 2 will cancel, and this 1/2 times this 2 will also cancel, and that would leave you with A plus B. All right, and we are almost there. I just need to get rid of this P. The P is currently multiplying times the 1/2, so I just need to divide it over to the other side. Divide by P, divide by P. My P's will cancel. That's a fancy 1, P divided by P. And then I'm left with the 1/2 that I needed. So 1/2 is equal to A plus B all over P. Weird, and essentially there's no real reason to have to do this. It's just that you are practicing your algebraic skills on a much, much higher level. Okay, this isn't the only way to do this. Let me show you another way. Let me add a little extra page here. And then I'm going to show you an alternative method. So I'm going to write my equation down again for my perimeter. Whoops. Okay, so this time I'm gonna factor out the 2. There's a GCF of 2 on the right hand side, and I can essentially use the distributive property to pull it out. Okay, now rather than get rid of the 2 like I did before by essentially multiplying both sides by half, I'm going to get rid of the a plus b. So the a plus b is being multiplied times the 2, so I'm going to divide it over to the other side of the equation. And have p over a plus b is equal to 2. Now look at what I have right here, and let me compare it to what I have over here. Notice that this a plus b is on the top, and down here it's on the bottom, right? Let me put them both on the screen there. So you can see that this one is essentially just this one upside down, and that's exactly correct. Let me make it a little bit more clear. This 2 here is the same thing as 2 over 1. And now what I want to do is essentially flip both sides. I'm going to take the reciprocal of both sides of an equation. And you might be going, what? I've never done that before. Can you do that? Let's see. Let me give you an example, again with numbers. So I'm going to take the fraction 1/2. And now just think of any fraction that is equal to 1/2, basically proportional. And I can do something like 2 over 4, right? And I'm going to take the reciprocal of both sides of my equation, and I'd have 2 over 1 on the left is equal to 4 over 2. Well, that's equal to 2, and 4 divided by 2 is also equal to 2, and I get myself another true equation. It's not equivalent to this one, but it is another true equation, which means that it's a perfectly valid step to do to both sides of an equation, which brings us back over here to this example. If I just flip both sides, I would have a plus b, that's a p, that's a b, over p is equal to 1/2. And that answer is equivalent, of course, to the one that we got the first time. All right, let's look at the next set here. Solve the triangle area formula for 2. Okay, so this seems like this is going to be very similar to the one that we just did, because there isn't a 2 in it, there's a 1/2 in it, right? Area formula is 1/2 base times height. So one of the things that I could do is just multiply both sides of this equation by the number 2. And there's the 2 that I need. Or I could do what I just showed you before and solve it for 1/2 and then flip it, right? I can essentially do this kind of strategy. Okay, let's say that I just decided to multiply by 2. I'd have 2a is equal to, this 2 and the 1/2 will cancel and leave me with bh. I need the 2 by itself, so I'm just going to get rid of the a. I'm going to divide the 2, not the 2 over, but the a over. Right, and they can cancel. And I'm left with 2 is equal to b over h. 2 is equal to bh over a. And again, like what we're doing here is just practicing our algebraic skills to be able to manipulate any equation. If this kind of thing makes sense to you algebraically, then most other algebraic tasks aren't going to be that much trouble for you. Okay, so let's look at number 5. Solve the trapezoid area formula for 1/2. Now this one does have a 1/2 in it. The trapezoid area formula is 1/2 times the quantity b1 plus b2 multiplied times the h. Now, while it might be tempting to distribute the 1/2 through here and maybe even distribute the h through here, I would suggest not doing that. The reason why is because if you do, then you're going to have 2 terms here that have a 1/2 in it. And we're trying to get 1/2 by itself. Let me highlight it. Notice that it's being multiplied times these 2 quantities. You can think of the B1 plus B2 as one quantity, and then the H as another one. It's all multiplication. So we can get rid of all of it at the same time by just dividing it to the other side of the equation. So B1 plus B2, all of this times height. And of course, on the right side of the equation, it's going to just cancel out. And it's going to leave me with the 1/2, which is what I was looking for. So 1/2 is equal to the fraction with A on the top, and then we'll have the quantity B1 plus B2 times the height on the bottom. Weird, but true. And then one more. Okay. On number 6, solve the circumference, the circle circumference formula for pi. You've got two options here. Let's say that I start with this one, pi times d. Okay, this one fairly straightforward. Solving this for pi, it's being multiplied times d, so I could just divide this d over to the other side. Flipping this around gives us p is equal to circumference over the diameter. As a matter of fact, that is the definition of pi. Pi is defined as the ratio of any circle's circumference to its diameter. Okay, but what if you used the other formula, which is c is equal to 2 pi r? We're trying to get rid of the pi here. So notice that both the 2 and the r are being multiplied times pi. Don't get rid of them in two separate steps. Get rid of them in the same step because they're using just a single operation, which is multiplication. So I can get rid of both of them by just dividing. Just dividing. Okay. And then on the left side, the 2's will cancel, the r's will cancel, giving me just the pi, which is what we wanted. I'll flip that around. Pi is equal to c over 2r. Okay, now this answer is equivalent to the previous one because 2 times the radius length is equal to the length of a diameter.